Welcome to lecture 9. Today we'll talk about abstraction, decomposition, and eventually functions. So a bit of recap, we have already seen how to use basic building blocks and how do we combine those together to create bigger constructs. For example, अगर आप data types पकड़ें, numbers पकड़ें for example, numbers को combine कर सकते हैं and to create expressions, और आप expressions को combine कर सकते हैं to create larger expressions. So this is an example where you can combine different type of data to create larger data structures. Similarly, जो दूसरा aspect है इसमें वो है code. आप डेटा को कंबाइन कर सकते हैं to create large data structure, and you can also combine code or instructions to create larger code. So अगर आप instructions को combine करें तो you'll get conditions and loops. हम देखा था कि loop की body में या conditions की body में हम multiple instructions को डाल सकते हैं अंदर, and we can write really large amount of code at this point. So that's all you need actually to write any program, any program that you want. And that's it. अगर आप Windows 11 भी लिखनी है तो you are well equipped with all the tools that you require to create really complicated software. But बड़े प्रोग्राम बनाने के लिए आपको काफ़ी सारी चीज़ों का बहुत ख्याल रखना पड़ता है. It's not just कि आप ये constructs यूज़ करेंगे और you'll have a really nice working program, बल्कि बड़े प्रोग्राम के लिए you need to know how to organize and how to reuse, because without reuse your code is going to be a real mess. So in order to organize, in order to reuse better, we must know what abstraction is and what decomposition is, and eventually after that we will know what functions exactly are, which is basically an application of abstraction and decomposition. So take a look at, think of an example, a smartphone. A smartphone आप एक black box की terms में सोच सकते हैं इसको. So smartphone has inputs and it has outputs, और जो अंदर सर्किटरी है वो हमें एग्जैक्टली आइडिया नहीं है कि व्हाट इज दैट अबाउट. ऑल वी केयर अबाउट इज व्हाट्स द इनपुट, एंड उस इनपुट के ऊपर डिपेंड करते हैं व्हाट्स द आउटपुट. सो इसी तरह मेरे पास ये एक छोटा सा डिवाइस है which is toy basically. इसके ऊपर आप देख रहे हैं कि you have this box, it's literally a black box, right? So इस black box के अंदर there is some kind of circuit, then you have these buttons, and these buttons are the interface. So इसको अगर हम press करें, this is going to turn this toy on, और इसके अंदर then you can press these buttons here, or when you press button and you can basically tell the toy कि अब आपने कौन सा button दबाया and then what action it needs to take. So these buttons or these joystick basically इसके ऊपर जो है, these are ways that the user can interact with this toy, and this is called the interface. And based on this input, what the toy is outputting is these colors and the position कि कौन सा वाला सेल आपने इस वक्त ऑन करना है. So you don't need to know the internal details of how it works, just like this toy. इसके अंदर हमें नहीं पता कि क्या है, लेकिन हमें इतना पता है कि जो हम input देंगे उसके हिसाब से it's going to work accordingly. And the only thing that we need to know is the interface कि कौन सी inputs आपने देनी है और उसके हिसाब से कौन सी output आपको चाहिए. And sorry, I have to get out of the way. And you need to know the relationship between the input and output. So that's the really important point that you must know. Even though code का नहीं पता कि black box के अंदर क्या है, but you need to know कि उसकी inputs क्या जा रही हैं जिसके हिसाब से उसकी output आएगी बाहर. So abstraction basically what it does is it just hides away the detail. It shows exactly the bare minimum. So this is hiding away all the circuit जो कि इसके अंदर है. It's a black box, और इसके अंदर it's only showing जिसकी ज़रूरत आपको है, which is interaction with these buttons, it's massively simplifying the complexity of the system, and that's exactly what we do with our code also. So real life में बहुत सारी चीजें हैं जिस which are actually abstractions. For example, अगर आप अपना स्मार्टफोन देखें, कंप्यूटर देखें, गाड़ी देखें, जिसमें आप you can steer and you can press accelerator, brake and gear, और आप हैंडल जब steering wheel जब आप यूज करेंगे तो depending on your input, the car is going to give you an output which is basically turning in certain. Alright, so decomposition क्या चीज है? Decomposition is essentially breaking a complex problem into smaller manageable pieces. अब जारी बात है कि जब आपने एक कोड लिखना है तो उसमें एक वक्त में सिर्फ एक ही चीज होनी चाहिए, एक वक्त में तीन चार मुख्तलिफ चीजें नहीं होनी चाहिए. दैट्स द क्रक्स ऑफ इट. सो फॉर एग्जांपल, अगर आपने कोड लिखा है, उसमें आप अगर उसी एक ही कॉन्टिन्यूस कोड में एज भी चेक कर रहे हैं, उसका सोशल सिक्योरिटी स्टेटस भी चेक कर रहे हैं, उसकी एम्प्लॉयमेंट हिस्ट्री भी चेक कर रहे हैं, तो दैट इज वेरी बैड. You should do exactly one thing at a single given spot separately. So that's the big idea. For every single piece of code or software that you want to build, you need to apply abstraction. That is, you need to put things in a black box so that you can reuse the black box again and again. And you also need to decompose into self-contained parts. And then you need to apply these two concepts to programming. What do I mean by reuse and self-contained and black box? So for example, let's say this is your piece of code. इसके अंदर अगर हम लिखते हैं x plus let's say round. Now this essentially is a call expression, right? और इस call expression का code हमें exactly नहीं पता कि इसके अंदर क्या है. We will treat this as a black box. We know what the input is, and we know what the output is going to be, and that is going to be the rounded value, right? So let's say 1 plus 3. So this is going to give us 5 as expected. So this is an example of a black box. And this does exactly one thing. It rounds up the value. It does not round, and then it also is not printing anything on the screen or doing anything other than that. Let's talk about abstraction, what abstraction exactly is. So basically, as we saw earlier, that abstraction is essentially, अगर आप real life में भी देखें तो it's about hiding details and revealing only the necessary pieces. So you can think of abstracted code as a kind of a black box जिसके अंदर हमें नजर नहीं आ रहा, but the only way to go inside is through those interfaces, those parameters that we talked about. So why do we need to do this? Because it hides a lot of tedious and complex details from the user. The user does not need to know how exactly that system is implemented. User basically needs to know how to use that black box. User does not need to know how the black box is actually implemented. And other bonus is that you can reuse the black box as much as possible wherever you want. So there is no copy pasting of code essentially. So that's what we did when we used our round function in our call expression, for example, or any functions that are a part of the math package. So the purpose of the coder is to actually put the complex details in the black box, but the user who wants to use your function, your piece of code, does not need to know about the code or to see the details for that matter. So here, if we take a look at these examples, for example, here in this case, so that's a call expression, and here are two parameters, and that's about it. The user cares about the parameters and what value is this going to return. So that's going to return 3. That's expected. So Again, the important point that we talked about earlier is the relationship between the input and the output. And that is very, very well defined in this case. But how this function is actually implemented, we have no idea. What about length? So it takes one single string and gives you the length of the string. That's also an expected output. But how this function, this piece of code, what kind of piece of code is written inside this function, this black box? Again, absolutely no idea. Same goes for max and same goes for round. The relationship between the input and the return value, that is very well defined. So for example, we know that if we give a bunch of numbers as input, we are going to get the highest number as the output in this case. And the round is going to just chop off the decimal part if it's the decimal part is lesser than 0.5. So this is going to return 2. So we know the rules. The rules, they are basically the relationship between the input and the output. But exactly what kind of code that's inside these functions, we have absolutely no idea. And we don't even need to know just to use this function. And that's the whole idea behind abstraction. So again, you can think of your function as this kind of a black box where you assign a name to this black box, which is the function name, and then you put your code in the function in this black box. The only way to get inside this black box is through the parameters. In this case, add has 2 parameters. So your parameters interact with the stuff that is inside this box, and then it churns out results, and then it gives you the output, which is incidentally in this case is 3. A black box can have multiple inputs, but it can only have exactly one output. So that's also one thing to keep in mind. How do we create a function? So function, again, function is a black box in which you put your code. So we have a def keyword, and that's built into Python. And then you have the name of the function that you want to create. And then you have these parentheses. So one parentheses is this one, and the other is this one. And then you have, super important, this ends with a colon. And inside the parentheses, you can give one or more a list of comma separated parentheses, parameters. And then you have something called the doc string. So doc string is a kind of description that helps the user to understand what this function is all about. The function who's using this, basically it describes the input and the output and the relationship between the input and the output. In this case, the input is a positive integer and the return value is going to be true if I is even, otherwise it's going to be false. So docstring is a special type of comment, which is a multi-line comment. It's a convention to put it right underneath the function, even though you can put docstrings anywhere. But you write the list of inputs, what they do, and then you specify what the return value is, if there is any. So the doc strings, they can be either 3 double quotes or 3 single quotes, and then you end the doc string with 3 double quotes or 3 single quotes. And then we have the body, and this looks very, very similar to what we did in our conditions or loops, for example. और अगर आप body में देखें तो there is something called a return keyword. So this return keyword returns a value back to where the function was called from. So this return value has to be the last instruction in that function that is executed. So when this return instruction is executed, the function stops right away, and then it just gives its control back to the piece of code that it was called from. So in this specific case, this function, this black box, basically what you do is it just you put a value in that black box, and then this black box tells you whether this value was even or odd. And when you know that how to check whether a number is an even or an odd number, we just see whether it divides by 2 or not. If it divides by 2, then we know that the remainder is going to be 0, and we compare that with 0. and hence that's going to return true. Otherwise, it's going to be an odd number. Here, there's an interesting thing to note that instead of writing that multi-line, multi-instruction if-else statement, you can get away with writing just a single line of code. For example, we know that given any number, if you try to divide it by 2, if the remainder is 0, it means that it perfectly divides by 2. And this expression in that case is going to, sorry, and this expression in that case is going to return true if I is even. So we just return the value of that. Otherwise, it's going to return false, and we simply return its value. So we don't need to check that explicitly in if-else statement, since that's going to be redundant anyways. Print and return, they are not the same. For example, in this case, we have again two functions with two different versions. One checks whether the number is even or not. Both of these actually try to check. But in the first case, that function is printing the result on the screen. It's not returning anything back, right? And the other case, it is returning the result back, which you can store in a variable. Since it's not returning anything, you cannot store the value back in the variable. It's just printing on the screen, which is not what we want. But now this function is doing two things. So that's a violation of, you can say, decomposition, because this is supposed to do only one thing. It just checks the number if it's even or not. But here it's checking the number if it's even or not, and also it's printing the result on the screen. So two things in one. This thing is doing just one thing. It's just checking the number whether it's even or not, and returning the result. So what happens when you return a result? In the first case, it just prints to the console and it prints none. So when there is no return statement in your function, it by default returns none value, right? So for example, in this case, if you do a equals to is even version 1 with the value of 3, it's just going to print the value, the result basically, and that's going to be false on the screen. And it's going to return none because there is no return statement, and it's going to store none in A. So basically, when you print A, when you use A is going to contain none. Whereas on the other hand, the second variant is returning a proper result. Now, since this return value, when it returns to the proper variable that is on the left side of the assignment statement. And then when you print B, in this case, it's going to be false. So that's the major difference between print and return, and you have to be very, very careful what you're doing with your code. To summarize, if you don't return anything, it's going to return none. And there's always a return value. By default, it's none. So A holds none and B holds false. What happens without the return statement here in this case? So what's going to happen is, when you invoke this function, so basically you're defining this function here. So this is, you're creating a black box. Now, when you define a function, it's not going to run, right? It's just creating a black box. That's it. In order to run the function, you have to make this call expression, something like this. So it's the name of the function, parentheses, and then you have to give the parameters there. So now this is going to invoke, and then that's going to return its value back to the variable from where it was called. Now in this case, as you know, as you notice here, that it's printing, it's not returning. So since this is not returning, as we saw previously, it's going to return none. So essentially, X is going to store none, and and the function is going to print hello, and the name is going to be Ali. So the final output is going to be, when you call the greet, it's going to go to the function, it's going to start running the instructions, and then it's going to print the statement which is hello Ali, and then it's going to return the value back, which is none, store none in X, and then it's going to print none. So that's going to be the output in the console if you run this code. So every Python function returns something if you don't write return. Python returns none automatically. So here's a big idea. Functions code only run when you call or invoke a function via a call expression. If you create a function, you define, so basically this act of creating a function is also called defining a function. When you define a function, it does not run the function. It does not run the instructions that are inside the function. That's very important. It only runs when you invoke it via the call expression. So in this case, there is a function called isEven, and here it has a parameter called I, and it's returning again the result whether I is even or odd. So here in this line we are invoking this function via a call expression, and it's going to return, in this case it's going to return false. So this thing here, when you're defining a function, this entire thing including its body is called the function object, and when you're invoking, that's called the call expression. And we have seen many call expressions basically in our previous sessions. So now what happens when you run this call expression exactly? When you run this call expression with the parameter 3, what happens is the value, the variable that was in the definition of this parameter is going to be replaced with the actual value that you specified in the call expression. In this case, it's going to be replaced with 3. And since that was replaced with 3, every single instance of I in your code is going to be replaced with 3. And here we can easily see that 3 mod 2 is not 0, it's 1. So this is going to return false. So that's false. And we also saw that every expression and also every call expression is replaced with a single value. So that's the return value that is being replaced with. So it's going to be false. Okay, now here's what I want you guys to do. Pause the video and try doing this. Try writing this code here. So what this code says is you need to define a function, and it says define a function, which it takes two parameters, two integers, and the integers are greater than 0, and it returns if t evenly divides n, otherwise it returns false. So again, there's a return value. You don't write, you don't print stuff on the screen. You explicitly return things from this function. And once you have written that, you test your code with these values and see if your answer is correct or not. So try it out and see what you can do. All right, welcome back. So let's take a look at the solution. In our Tony, what we're going to do is we're going to write the definition of this function. Basically, this is going to be just like we did the evenness test. It's checking whether n when divided by d leaves a remainder or not. If it doesn't leave a remainder, that means that it's exactly divisible by d, otherwise it's not. So let me show you. When you run the script, this function object gets loaded in the memory, and then we can simply do call expressions here. So def by what the exercise says, it says you need to test it on two values, 10 and 3. So that's obviously false because 10 is not, 3 doesn't divide 10. And what about the next one? So if we press the up arrow key, I suggest that you try doing it now. Try pressing up arrow key, so it displays the previous command. Up and down arrow keys basically. And 195 divided by 3, that is true. So that's how you do it. Scope essentially means lifetime of an object or a variable. For example, if you create a variable a and put a value in 3, and then you create a variable with the value 4, and then see that the result of this expression a plus b. So what's the lifetime of a, b, and c? That's the question. And the lifetime of a, b, and c is the entire lifetime of the program. So the lifetime of the program, if a variable has a lifetime of the entire program, then we say that that variable has a program scope, because these variables will live as long as the program is running. For example, you have this function object, this thing that you see over here. So that's a function object. And again, this is just checking the number, if it's an even number or an odd number. Now, what happens when you call this call expression, and you invoke this call expression with the value 3? So basically, it's going to compute stuff, go into the black box, and then it's going to return the result in A. And this is going to return the result in B with the value, or whatever that is when you pass 10 as a parameter. And then same thing is going to happen with C. So all of these call expressions are going to return some value in their variables. But the question is, what's the scope of A? What's the scope of B? What is the scope of C? And what's the scope of I? Is the scope for all these variables the same as the program scope, uh, or is it something different? So let's look at that. So when you create a function object, this is basically kind of like a variable called isEven, and the function object is going to be stored in that variable. So just like you say a equals 3, 3 is stored in a, here isEven essentially behaves like a variable which stores or points to the code that you have in the memory. So that's a function object. It's a special kind of variable. And then you run this call expression. Now this returns false. So the value false is copied to the variable a. And then when you call isEven with value 10, it returns true. So B contains true. And with the value 1, 2, 3, 4, 5, 6, this returns true also. So C contains true. Please note that all of these variables will remain alive as long as the program is running. Now consider another scenario. We have A that contains the result of squared 5, and then we have B that contains the result of squared 3. And square itself is a special variable that points to the function object. Now, what about X? What is its program scope? So the scope of all of these three variables, squared, A, and B, is the lifetime of the entire program. But what about X? Is the lifetime, does X live as long as the program is running? Or is it somewhat much short-lived? So the answer is, we will learn about that in the next lecture, but just a heads up, the scope of X is much shorter than A, B, or square variables. So it's not program scope. Can we use functions inside like other constructs? So yeah, of course, we have already seen this syntax like these, in which we can use call expressions, and the value that this call expression returns is going to be replaced with that, and then be used in this Boolean expression or condition. So this is going to return either a true false value or a truthy falsy value, which will convert into a Boolean value. So that's a big idea. Don't write code right away. Always write your idea and the code on a piece of paper, think about it, check a few values on it, and then you start writing. And make sure that it's working as best as you can, and then you can start writing code on the computer. So suppose that we want to add all the odd integers between and including a and b. How do we write this? So let's start with a very simple example, and we systematically solve this example. What we have here is a black box with two parameters a and b, which are the input, and what we know that the return is going to be an integer, which is going to be the sum of all odd numbers between these two values inclusive. So now what we need to do is we need to think about how we fill this code in. So let's start with very, very simple and small examples. Let's say a is 2 and b is 4. The sum of odds, and you should solve this on the paper, should be 3. And you should solve it on the paper for a few smaller values. For b and 7, it should be 15. And add all numbers between a and b inclusive. So basically, if it's saying in the description that you need to add all numbers between a and b, and you don't know what a is and you don't know what b is, so it's kind of pretty much like it's going to be a loop, because you're going to start from a, and you're going to skip one item, one even item, go to the odd item, and then you keep on doing that until you hit b. So this, your code here comment becomes a loop. But now you have choice whether you want to use a for loop or you want to use a while loop. You can do exactly this using both of these loops. So if we use for loop, what do we do inside the for loop, or what do we do inside the while loop? So again, we have exactly seen the template for the while loop. It has the starting variable, this loop variable, it starts from a, and there's a condition, and it loops until this condition is true. It loops till the condition is true until this is false, and this is a loop variable which is incrementing. If you don't increment, it's going to be an infinite loop, and they do something inside. So pause the video, and I want you guys to fill in this do something comment with useful thing which actually adds all the odd numbers between these two values. Pause, and then we'll return in a few seconds. So what we do is we just create a variable called sum, which initializes from 0, and this is going to keep the running sum of all odd numbers between these range. And since we are starting from a going till b, so basically at this point, sum of odds is not the sum of all odd values. It is the sum of everything, even and odd, everything inclusive. So you can say that this is a bug at this point, but we can fix it pretty shortly. So again, pause the video and see if you can fix this bug. So it's pretty easy. I mean, you add values to sum of odd variables if and only if the value is odd. So that's what sum of odd means in both cases, right? So as you can see that in order to write code, we just keep on adding things systematically, one thing at a time. We don't try to add everything all at once, and this is going to create confusion. All right, so we can rewrite instead of using. So again, take a note at this statement here. This says if is not even, then you add the odd number to it. Can we reuse our black box? Because what's the point of creating a black box if we are not reusing the black box, or if we are using those internal instructions that are inside the black box? We don't want to do that, right? So here the rule is, once you have created a black box, never use or copy its internal instructions. Always use the black box, or always use the function. So here we want to use, instead of manually directly checking whether it's odd, we just simply create a function called odd, which is going to reuse the function called is even, because if it's not even, so if it's even, if it returns false, it means it's odd. So we invert that, it returns true. And this function is going to reuse is even. Again, we are reusing black boxes, and that's the entire crux of this lecture and the entire summary of abstraction: to reuse and to hide complexity. Never duplicate code. So here, you try this, pause the video and write a code that satisfies the following specification. So n is a number, for example, n is a positive integer, and your code, you have to write a code which tells whether n is divisible by both 3 and 5, right? So one naive way that you can do is you can do it as the following. So let me just quickly copy and paste it here. So you can say, okay, fine, we need to check whether it's divisible by both. So if n mod 3 equals to 0 and n mod 5 equals to 0, then we return true. Or in fact, as you saw, we can simply return the value of this expression, which is the shorthand return that. So both of these two conditions need to be true in order for a number to be divisible with both 3 and 5. But again, here there is a problem, and the problem is that we already had defined a black box, and that black box was called div by, right? So what you are doing here is you are just using those internal instructions, you're copying those outside the box, and then you're using it openly in the code. So that's a big problem, and that's exactly defeating the whole purpose here of creating a black box. So instead of doing this manually, what you can do is you can reuse the black box which we created earlier and replace with div by. So pause the video and see if you can do it. Replace both of these by div by, and we'll take a look at the solution in a few seconds. So welcome back. The first one, obviously that's easy. It's going to be if n is divided by 3. So we replace this, we reuse the black box, and n is divided by 5. If both of these return true, we know that the number n is divisible by both 3 and 5. So that's the proper way to do it. So you can test your code with a few values of it. That's a very good idea. Once you've written a code, then you need to test it with a few values. All right, another example here. Can you write a code that satisfies the following specification? So is palindrome a function that takes a string as an input and then it returns with true whether s is a palindrome or false otherwise. So palindrome is a string. When you reverse it, it stays the same. For example, madam, if you reverse the string, it stays exactly madam. So it's a palindrome. ABC is not a palindrome because if you reverse this, it becomes CBA. So it should return false. So how do you write the function, its body? Pause this video, think about it, and we'll return after a few seconds with the solution. So in the strings lecture, we saw a step, especially a negative step, in how to reverse a string. Essentially, what we are doing is we are comparing the string and we are reversing the string with by giving it the like negative step, and then we are comparing these two strings. If the string and its reverse are both exactly equal, it means that it's a palindrome, and it should return true, because it's only going to return true if both of these are equal. Otherwise, it's going to return false. So that's a very handy way to check palindromes. Let's talk about default parameters. The case is essentially, let's say that we already have written a function called square, so that squares any number that you give as a parameter. But what if you want to compute cubes also? Then you have to write another function that computes the cubes, right? Consider this function called power. It takes one single integer, it just squares the number, and then it returns the value. So if you want to compute the power of 5, it's going to give you the square of 5 and the square of 3. But if you want any other power apart from square, then what do we do then? So for example, if you want cube or power of 4, so that's what we need to think about. What we can do is we can pass another parameter, that is the power. So now we are passing two parameters, the number itself and the power to which it's going to raise to. And again, the solution is the body is going to be x power n. Now note that if you want a square of a number, you pass 2 as a power, and if you want a cube, then you pass 3 as a power. So, but the thing is, let's say 99.9% of the time, you just want to square a number, and very, very rarely you want other powers, but you do want other powers. So we cannot completely eliminate this code. We need power as a parameter, but majority of the powers are going to be squared. So in this case, even though we are computing square majority of the time, we have to pass 2 every single time. So is there a better solution? Yes, and that's called the default parameters. Default parameters look something like this. So when you write this assignment statement equals to some value right in the parameter, it becomes a default parameter. What default parameter does? So note that you did not specify the second parameter in this call expression. It's just 5. There is no power here. Now, when you miss the default parameter in your call expression, it's going to assume the default value. So in this case, since you missed the power, the value of n here, it's going to assume the default value, which is 2, and it's going to take the square. So now, since we are taking the squares majority of the time, we don't have to type 2 with all the call expressions. But if we want to take some other power, then we can specify that value of n, and when you specify the value of n, it's going to overwrite the default value, and the value that you specified will be used. So for example, in this case, it's going to use 3, not 2. So to summarize, 2 will be used when you skip the value, otherwise it's going to use the value that you specified. So the default parameter must go at the end of the parameter list. So for example, here we are skipping the default parameter, it's going to assume the default value, which is 2. Here we are specifying the value, it is going to assume the new value that you specified and not the default one. And you can also specify values like these names equals to the value here. And the benefit of that is that you can swap the order when you specify the names, and it's going to pass in the values with the correct parameter order, right? So this is the same as saying that x equals to 5 or n equals to 3 with the order reversed. But with the stuff that is not okay is that the problem with this line number 2 here is that the default value is not in the one of the last positions in the list of parameters. So you cannot have that. Whenever you're specifying the default value, it has to be in the function, it has to be one of the last ones. And what about this one? So here we even though we mean that n is 5 and x is 3, but since we are not specifying the names, so the function is going to assume incorrect values for n and x. Again, there's a common mistake, which is basically you defined a function. So this is a function object, but there's no return value here. Again, just recall a couple of slides earlier, we talked about that if you do not write an explicit return statement, then it's going to return none. So in this case, even though we think that it should return x multiplied by 2, but it's not. It's returning none. So if you want to return this value, you have to explicitly specify the return statement. Another common rookie mistake is that you print the value instead of doing returns. So when you print, it will not be stored in some external variable. If you return, only then it will be stored, that value will be stored in a variable. So print cannot store the results, return can. How to invoke a function call. So invoke a function call, it's not just the variable name. In fact, it's the variable name with the parentheses and the list of parameters inside those parentheses, the value of those parameters. So yeah, that was it for today. And we talked about essentially abstractions, why do we need to create black boxes, and once you have created a black box, you must essentially try to always use that black box and do not redefine the code that is already written in the black box. So that is the entire most critical takeaway point of this lecture. And always try to think on, or at least dry run your code on a paper with smaller values, and incrementally try to develop, add features in your code. And the scope means the lifetime. Some variables live for the entire lifetime of the program, and some variables they don't, which we will see in the next lecture. And then we talked about the default parameters. So in the next lecture, we'll talk in detail about the scope, the environment variables, and how function calls are made and what happens in the memory when they are done, when they are made. So see you next time. Bye bye.